Welcome to this explainer. Okay, think about your application right now. Every single time your app calls the Claude API, you are literally paying to reread the exact same system prompt, the exact same documentation, and the exact same tool definitions, over and over. If you have a busy application, this constant rereading is just a relentless drain on your budget. But today, we're going to look at an advanced Claude feature that stops this budget drain in its tracks: prompt caching. Let's dive in.
100%. Look, if you're running a busy customer support bot that fields hundreds of questions an hour, paying the full 100% input cost for all that static reference material isn't a bug in your code. It's actually just the default behavior of the API. By default, you see, the model has absolutely no memory of the static context you sent it 3 seconds ago. You send a giant chunk of text, it processes it from scratch, and yep, you pay full price. You send the exact same text a minute later, you're paying 100% again. It adds up incredibly fast, and it seriously limits what you can afford to build. But implementing prompt caching changes this math entirely.
So the crucial point is this. When you successfully utilize prompt caching, those cached tokens cost only 10% of the normal input token price. And that translates to a staggering 90% reduction in cost on every single repeated read. For a document-heavy pipeline that's processing hundreds of requests a day against the exact same context, a 90% discount is not just some minor rounding error, it is very often the deciding factor in whether a complex, context-heavy AI feature is actually economically viable to run in production at all.
So how does it work? Well, prompt caching is an API-level feature that stores the computed state of your prompt's prefix right on Anthropic servers. Without caching, your full prompt travels to Claude, and as we know, you pay full price. To fix this, you simply add an ephemeral cache control marker to the last block of your static content. Everything from the top of your payload down to that marker gets cached. On the first request, the usage response confirms the cache write. Then, on the next request that starts with that exact same prefix, Claude just skips the expensive reprocessing. It loads the saved state directly, yielding that massive 90% discount.
And this brilliantly illustrates what we can call the one example you really need to remember. Imagine a sauce company running a customer support bot. Its system prompt contains persona instructions and product documentation totaling, say, 350 tokens. Customer 1 asks how to enable Cloud Sync. The API sees the cache control marker and writes those 350 tokens of documentation straight to the cache. A minute later, Customer 2 asks a completely different question about rate limits. The request goes out with the identical system content, but this time, Customer 2's request pays literally pennies on the dollar to read the exact same documentation. During peak hours, that 350 token block is written exactly once and then read incredibly cheaply by everyone else.
Now, before you start building, you absolutely must know the constraints. First, there's a 1,024 token minimum threshold. Second, caches live for 5 minutes by default. You can opt for a 1-hour time to live for workflows with bigger gaps, but just keep in mind the right cost for that option is higher. Third, if you're using platforms like AWS Bedrock or Google Vertex AI, automatic top-level caching won't work. You absolutely must mark individual content blocks explicitly. And finally, no dynamic content. You have to keep things like timestamps, user IDs, or any session-specific variables entirely out of your cached blocks.
Which brings us to our ultimate key takeaway. Prompt caching is a one-field change that makes long-context Claude workflows 90% cheaper to run on repeated reads. To achieve this, you've got to structure your API requests so that all static content, the system prompts, the tool definitions, the long documentation, always comes first. Then, you precisely mark that last static block with the cache control marker. Finally, and this is crucial, actively monitor your usage. If cache-free tokens are climbing, great, you're saving money. But if you only see cache creation tokens, something in your prefix is changing and your savings have completely evaporated. You need to find that changing variable and fix it.
So, I have to ask you, are your dynamic variables secretly destroying your cache right now? Are you writing to the server over and over again without ever getting the discount? Look, it's a common trap, but it is entirely fixable. If you want to dive deeper, see 3 fully worked examples, and learn how to avoid the most common implementation pitfalls, definitely check out the full chapter in the Claude Master ebook at claudemaster.net. Thanks for joining me for this explainer, and happy building.